Okay, welcome to Hot Topics Chapter 4. We're going to help review some of the factoring methods that are shown in ALEKS because we realize out of everything, ALEKS does have its unique way of discussing factoring, and we're just going to try to simplify it for you here and make your lives a whole lot easier.
Right. Factoring is one of those two words that people most dislike in algebra. Factoring, what's the other one?
Fractions.
Yeah, fractions and factoring. So we're going to try to make this a little bit easier. I'm stealing a lot of this from actually how Jerry teaches this because it seems to me this is probably the easiest way to do it. All right, so first we're going to talk about factoring trinomials. These are what students typically think of when they think of factoring problems. It's a trinomial because it has three terms, that is three pieces. And what we recommend that you do is you look at these backwards. You look at this number here and this number here. For now, I'm ignoring the signs. I'll worry about them later. I'm looking for numbers that when I multiply them, they give me 6. And when I subtract those numbers, I want to get an answer of 5. So over here, I write my multiples of 6, or factors of 6, excuse me. That's 1 times 6 and 2 times 3. I'm looking for the numbers that when I subtract them, I get 5. Those numbers are 6 and 1. So I can go directly now to my answer. I know my answer is going to be x plus or minus something times x plus or minus something. What I want to end up with is negative 5. To get negative 5 from 6 and 1, I would have to add negative 6 to positive 1. And we should point out you can also write your answer in the opposite order. You can write the answer as x plus 1 times x minus 6. The order doesn't matter. And that's the factorization. That's it.
This was a very good example because a lot of times we see students take the 2 and the 3 because they're not checking that last sign. We call that the indicator sign, that sign in front of the 6. And if that sign is negative, the factors must be subtracted to get the middle term. If the last sign is positive, they must be added to get the middle term. If you try it any other way, it's not going to work out.
Right. So as an example of what Jerry's talking about, let's look at the second problem. This time I need numbers that multiply to 16, and this time I need those numbers to add to 10. Again, I'll worry about this sign last. I don't like to worry about that in the beginning. So over here I have my factors of 16. They are 1 and 16, 2 and 8. 3 doesn't go into 16. 4 times 4 is 16, and that's it. I'm out of numbers. And I'm looking for the ones that add to 10. Those numbers are 2 and 8, so I can set up my parentheses. It's going to be x plus or minus something times x plus or minus something. And I want the numbers to add to negative 10. To get negative 10, I would have to add negative 2 and negative 8. So this is the factorization, x minus 2 times x minus 8. And again, the order doesn't matter. If you wrote down your answer, x minus 8 times x minus 2, it would be also correct. Okay, so now let's look at the trinomial problems that are a little bit more difficult. What makes these problems more difficult is that instead of there being a 1 here, there's a 5. And Jerry and I are going to show you the way to do this that we find the easiest, that we think students find as simple as possible. In particular, I prefer this method to the trial and error method. However, if you know some other way to factor these and your method seems easier than the method we're showing you, feel free to use it.
Yeah, we believe ALEKS uses trial and error, so if you like that method, you're probably not watching us right now.
That's a good point,
If you don't like it, we're showing you an alternative,
right.
And our book is written with that alternative.
Right, this is the way the book also uses. All right, so for these problems, we start by multiplying this number by this number. 5 times 6 is 30. So now I write down the factors of 30. Those are 1 and 30, 2 and 15, 3 and 10, and 5 and 6. You can check. Those are the only factors of 30. And I'm still looking for numbers that subtract to 7. So looking at my list here, here are the numbers that subtract to 7. All right, so here's the most important step. I copy this down. I copy this down. And I rewrite the middle term, positive 7, in terms of 3 and 10. Positive 7 is positive 10 minus 3. And the 7 has an x, so bring the x down and take it along for the ride. In other words, positive 10x minus 3x would give us positive 7x. And now the worst of it is over. All we have to do now is a little bit of factoring by grouping. To do that, we just factor the first two pieces and we factor the second two pieces. Here, I can pull out both a 5 and an x. That'll leave x plus 2. 5x times x is 5x squared. 5x times positive 2 is positive 10x. Here, if this third sign is negative, always pull out a negative number. Here I can pull out a negative 3. And if I do that, it will also leave x plus 2. Negative 3 times x is negative 3x. Negative 3 times positive 2 is negative 6. Finally, there's an x plus 2 here and x plus 2 here, so I can factor.
Let's pause for a second.
Okay.
If you don't have identical terms in those parentheses, you've made a mistake.
Right, exactly.
Stop and go backwards. They have to be the same to proceed on.
Right, if that's the way this method works. If they're not the same, you've made a mistake. Okay, so finally, again, there's an x plus 2 here and an x plus 2 here, so I can factor it out. If I take away the x plus 2's, all that's left is 5x minus 3. And this is the factorization of the original problem. Again, these problems are a bit long, but as I always tell my students, it's better to factor slowly and get the right answer than to factor quickly and get the wrong answer.
Good point.
All right, so let's look at another example. This one will have a plus sign. Again, my first step here, multiply these numbers to get 28, and now make a list of the factors of 28. They're 1 and 28, 2 and 14, 3 doesn't go into 28, but 4 does, and I think that's it. And this time, I'm looking for numbers that add to 16. Those numbers are 2 and 14. So as I did before, copy down the first term, copy down the last term, and then write the middle term in terms of these numbers you just got. Positive 16 is positive 14 added to positive 2. So positive 16x is positive 14x added to positive 2x. And again, the worst of it is over now. The rest of it is just factoring by grouping. Here, I'm just going to factor these two and then factor these two. And here I can pull out a 2 because 2 divides into both 4 and 14. And also I can pull out the x. If I do that, what's left here is 2x. What's left here is plus 7. Let's check that. 2x times 2x is 4x squared. 2x times positive 7 is positive 14x. Here, it looks like there's nothing I can factor out, but you can always factor out a 1, because 1 multiplied by anything will give you the original expression. So positive 1 times 2x plus 7 will just give us 2x plus 7. And now we have a common 2x plus 7. I can factor that out. These two leftover pieces, 2x plus 1, make up the next factor. And so this is the factorization of this one, I think.
And just so you know, we would never factor out a 1 on any other problem other than this one. But Bill and I both know that if we don't put that 1 in front of 2x plus 7, a lot of students end up leaving us with a term with just 2x. They don't know that there is an imaginary 1 in front of every binomial that exists. We just only write it in this case so that the students know to carry it over. So anyway, don't expect us to require you to factor out 1s on anything else.
Right. This is just the way these particular problems work out.
Yeah.
All right, let's look at one more example of this. Now, if you followed my advice for the other problems, your first step would be to multiply 30 by 24. But 30 times 24 is going to be a gigantic number. It's 720. And we don't expect you to list all of the factors of 720. So chances are there must be some sort of common factor that could be pulled out of this beforehand. Jerry always calls this Rule 1. The first thing you should look at before you factor any problem is look for a common factor. And here, if you look at 30, 6, and 24, there is a common factor. 6 divides into all of these numbers. So before I do anything else, I'm going to factor out a 6. If I do that, that will leave 5x squared plus x minus 4. 6 times 5x squared is 30x squared. 6 times positive x is positive 6x. 6 times negative 4 is negative 24. And now these numbers look a bit more reasonable. If I now multiply 5 by 4, I'll get 20. My factors of 20 are 1 and 20, 2 and 10, and 4 and 5. And I'm looking for factors that subtract to 1. Remember, if you don't see a coefficient there, it's understood that it's a 1. Those numbers are 5 and 4. Now, this 6 is part of your final answer, so don't forget to keep bringing it down. So I'll bring down my 6. The rest of this, I'll do exactly what I did in the previous screens. Copy down the first piece, copy down the last piece, but write positive 1 in terms of 5 and 4. Positive 1x is positive 5x added to negative 4x. And now I got to do some factoring by grouping. I'll factor these two pieces, and I will factor these two pieces. Keep bringing down the 6. Here I can pull out both a 5 and an x. That'll leave x plus 1. 5x times x is 5x squared. 5x times positive 1 is positive 5x. Here, again, if this third sign is negative, you always want to factor out a negative number. So I'm going to factor out a negative 4. That will also leave x plus 1. Negative 4 times x is negative 4x. Negative 4 times positive 1 is negative 4. So my final answer is 6 times the thing you wrote twice, x plus 1, times these leftover pieces, 5x minus 4. And that's the factorization. All right, Jerry, where's this in the book?
This is all in Chapter 4. Just look for factoring. I believe the first 2 sections cover factoring. We've kind of blended a couple things here to make your lives easier for those of you that just want a couple questions.
Right, because we figure that if you're looking at factoring, there's a good chance these are the problems that are giving you the trouble. So we hope this helped, and maybe we'll see you in the next Hot Topics.